Hello everyone, welcome to another video. In this video we are going to discuss about Docker networks. Okay, we are going to see some introduction to Docker networks and see some basic examples and most commonly used network types. Okay, so first thing that we would need to understand is what is a Docker network. So by default, when you run or create containers, or the definition of container itself is isolation. Okay, it's a way to isolate, and that isolation means that containers should not be able to communicate between themselves because they are isolated from one another. And networking is the mechanism on which you can allow containers to communicate with one another. Okay, without this networking, it's not possible actually to have containers speaking with one another. Okay, and so when you have containers isolated on networks, okay, you can avoid conflicts between the containers on the network and the host system. As an example, you can have on a specific network a container running on port 80, and on another network the same container running on port 80, and you don't have this conflict with the host itself, meaning your computer or the Docker server, ports 80. Okay, so you don't have this conflict. Okay, so networking allows you to put containers in a way that they can communicate with one another, but also with networking you can control which containers can speak to which. Okay, so you have ways to apply some kind of policies that allow you to prevent specific containers on one network to communicate with containers on other networks and so on. So you can have this kind of policies being applied. And lastly, containers, they can belong to multiple networks. Okay, so one container doesn't necessarily have to belong only to one a network. It can belong to multiple networks. Okay, and so having this know-how about Docker networks is useful because you use this all the time. And when it comes to Docker network types, you normally use two main network types, and these are the ones we are going to focus today, which is bridge network type and host network type. Okay, but before we move on to this technical explanation, like everything in Docker, you can check if this resource exists or not with the docker network ls command. Okay, so this command allows you to check which networks you have locally created. Okay, and as you can see, I just have three basic ones, and this ones come quote unquote for free when you have Docker running, so I don't have any extra ones. And as I told you before, in this video we are going to discuss two main types of networks, the bridge one and the host one. Okay, we are not going to address any other network types as they are rarely used. These two are normally the most used, even though in most scenarios you would only use bridge. But sometimes it might be useful to know how to use the host one as well. So starting with the bridge one, with the bridge network. So whenever you start Docker, as I just showed you, you have these three types of networks by default, and you also have the bridge one. And whenever you create or run a container and you don't specify the network on which this container will run, okay, because when you do a Docker run, you can specify -- network and specify a network name, okay, and this will automatically make this container run inside this network, okay, and we will see this in a second. But if you don't pass this option, by default the containers will run on the bridge network, the default one that Docker creates, okay. So if you don't specify anything, they will fall under this category here. We will see this also in a minute. And the only issue with not specifying the network specifically, if in case it's bridge, is that this default network here, the bridge one, if you don't create another bridge one, it does not have some kind of DNS resolution. Okay, so you cannot target containers by name, okay, as you would if you were to create a bridge network manually, okay. So behind the scenes, what happens with this bridge network is that Docker creates a Linux bridge interface on the host, in this case in our machine, okay, and then every container that is attached to this bridge will get an IP on an IP sub-range of the bridge, okay. So this was a bit confusing, so let me explain. There's another command you can run, which is called docker network inspect, okay, and this will allow you to see the details of a specific Docker network. And if you pass in the Docker network name, which in this case is bridge, why is it bridge? Because when we did Docker network ls, that was the name of the network here. So if we do docker network inspect bridge, it will allow us to see the details of this network, okay? And one of the things you will see is that this bridge network has a subnet, okay? And whenever you attach a container to this network, that container will have an IP address that is a part of this subnet, okay? So that's one of the things that happen behind the scenes when you create a network of type bridge and you attach containers to that bridge, is that the IPs of the containers, they will be on a range that is on this that respects this subnet the subnet restrictions, okay. So just as a temporary summary for what we just covered for this bridge network, this is the default network in Docker, okay. So when you don't specify it, this is where your containers are attached to. If you don't create the bridge network yourself and use the default one from Docker, you don't have the DNS resolution by default. This means that you cannot call a container by its name. And also, if you create one by yourself, you have it. And also, containers, when they are attached to this bridge network, they will get an IP address that is a part of the bridge subnet IP range, okay? So let's see this in practice, okay? So what we will do now, we will create or see two examples. One of them is having two Nginx containers running on the default bridge network, and see that actually, even though they can connect with one another by IP address, they cannot connect with one another by name resolution, which is what I just told you. And the second example we are going to see is we are going to take the same DNS, the same two Ubuntu or Nginx images and or containers. We are going to put them on the same network bridge that we are going to manually create. And we will see that effectively they can not only communicate with one another by IP address, but also you are able to have DNS resolution. Okay, let's start with the first example where we have two Nginx containers, both running in the default bridge network, and we will see that effectively we can connect with one another only by IP, and we cannot resort to the DNS name resolution. Okay, so let's run the first Nginx container here, and we will run it with a bash just to get inside the container and to be able to connect with the other server. Okay, this could be actually any container, doesn't necessarily have to be Nginx, but since I know it has curl inside, it's useful. So minus or minus IT minus name Nginx I don't know, bridge 1, let's say bridge 1, and Nginx bash. So we haven't specified the -- network option here, which means that this container will go by default to the bridge network. Okay, and let me copy this command here and open it on PowerShell, and don't want to use bash because I actually want the server to run. And let me do like this, adjust the name, and this should run the Nginx server. Okay, so as I showed you before, there is a way to check the details of the network, and one of the informations that you can extract from those details is the containers that are attached to that network. So if we do docker network inspect bridge, which is as we've been speaking, the default name for the default network. Okay, and if you see here, there's this container section where you can see the containers that are attached to it. And you can see that we have Nginx bridge 1 and Nginx bridge 2, which are the ones we just created. And notice also here something important. So the IP subnet is this one. Okay, and notice that the IP addresses of the containers, they respect the subnet restriction. Okay, so this is also one thing that is very important to understand, as we spoke previously about IP addresses in bridge networks. Okay, the bridge itself sets a subnet rule, and all the containers that are attached to that network, they have to abide by this subnet rule. Okay, so they have to respect it. Okay, and so I'm here inside network bridge 1, and my intention is to see if I can get the content of the Nginx server running, which is Nginx bridge 2. So if I go to Nginx bridge 2, I can copy its IP address, okay, and come here and do a curl. And when I do the curl, you should actually see that I get the content. And this is the default Nginx page if you've ever worked with Nginx. So you get the content of the page. Okay. So you can actually, the containers, because they are on the same network, they can communicate with one another. What you cannot do, because you're on the default bridge network, is to do a curl by host name. So as you know, the server, so this is 1, this is server 2. What you cannot do is to do this. Okay, you cannot curl or do any operation that implies DNS name resolution. Okay, so in this case, again, if I replace the host name for the IP address of container 2, I would get a response back. Okay, just to prove the point that there's no DNS name resolution in the default bridge network. Okay, so let's exit the containers. So the first one and then the second, or in this case, I exited out my PowerShell. Did not want to do that. And let's now go to the second part of the bridge network exercise, which is to have the containers be a part of the same custom bridge network. And when we do so, we will see that the containers, they can not only route by IP address, but also by DNS. Okay, so the command to create a network, it's called docker network create, and now you create a network name. Let's call it my net for simplicity reasons. Okay, if I do docker network ls again, I should be able to check my newly created network, okay, which is of type bridge by default if I don't specify the driver type. And so now, since I have my network created, whenever I run my containers now, okay, so in this case, bridge 1, there's already a bridge 1, so let's call it custom bridge. Okay, I can specify here -- network and specify my network name, so my -net. Okay, and this will execute this container, this nginx container, inside this network. Okay, we will see in a second that this is actually true, but let me just copy this command, go to my second PowerShell, and do custom bridge 2 and remove this iterative command because I want the server to run. Okay, now how can we actually see that the containers are now running on that network? We've seen this before, so I need to do docker in network inspect, and I need to pass my network name, so in this case my net. And first, let's see the subnet restrictions. So as you can see, the subnet is this one. And again, the IP addresses that are assigned to the containers, they follow this subnet rule. Okay, so in this case, it's 02, and in this case, it's 03. So they respect the subnet rule. And you can see, of course, here under the container section that indeed we have the two containers that we've specified to run under that network. Okay. Now let's see in action from container 1 that we can curl nginx on container 2, both by IP and by host name. So I'm here on our network details, and let me get the IP of the second container. So this used to work before, so expect it to continue to work. Okay. So when we do curl by IP address, we see indeed here that we get the contents of the page. But what happens if I now also do by this host name, or in this case, the container name. So if I do curl container name, in the default network bridge, there was no DNS name resolution, but here, since I manually create this network bridge, it comes with the DNS name resolution. And if I do this, I get the page the same as if I was to do it by the IP address. Okay? So hopefully, with this simple example, you can see the difference between having the containers operate on on the default bridge network and operate on a custom bridge network. And that's very important, because if, for example, let's assume you're running your application and you want to containerize your microservices or whatever you're using, and its dependencies like RabbitMQ or SQL Server or whatever you're using. If on the code you're specifying the container name or the expected container name, and all of a sudden that doesn't work, then maybe it's because those containers are running on the default network bridge or bridge network, and they simply don't have DNS routing or name resolution. So everything is nice with your code, it's just that you're running on the wrong network. So I would always advise on create your own network or own bridge network, and that should suffice, and you shouldn't have any issues. But by default, when you normally use Docker Compose, and normally you already have the networks created there, so you normally don't have any issues, but beware that that can happen. So now let's go to the second type of network that is commonly used, which is called the host network. Okay. With the bridge network, we have this isolation on the containers. The networks isolate the containers themselves. But when you have the host network type, there is no network separation. Okay, the containers, they will run on the same network of your host. Okay, this means that there is no isolation at all network-wise. Okay, which means that you can potentially have things like port collisions, because since everything is now on the same network, well, port 80 is being used. So, I mean, bad luck. So you don't have the benefits of network isolation. And so, yeah, so that's one of the things that you get out of this host network, is that you merge whatever networks you have with the host network. There's no network isolation. And since there's no isolation, normally this option is a bit more performant, because you don't have all the overhead of the isolation. But I don't personally recommend using host network types unless you're on very specific occasions where you may need some quick debugging and so on. If you are using Docker desktop on Windows and Mac and maybe Linux, this host network option comes disabled by default. Okay. So you have to manually opt in for this option. So let me show you how. If you go to settings and you go to resources, so I'm on Windows, and if you go to network, you will see here that I have this host network enabled and I have it enabled. And if you don't have it, as I said, it doesn't come by default. And if you don't have this enabled, you have to enable it in order to use whatever I'm about to show you next. Okay. Anyway, Now let's go back to this host container explanation. So let's see a quick exercise here. But before we go, there's another small detail that I need to cover regarding this, which is because you're on the host network, there's no need to pass the -p option when you run the containers. So normally when you run containers, you can do something like docker run, and you have the -p to publish the ports from, I don't know, 8080 to 80 inside the container. So this is needed only because there's this network isolation. But because there's no network isolation anymore and everything runs on the host network, you don't actually need to pass the -p option if you want to have the ports published on the host machine, because they are already there if you use the host network option. Okay, so beware of that. So let me prove a point here. So let's execute those ones, and let me delete all the containers. Let's have a fresh start. And let me run here the container network bridge 1, but instead of running it on the network bridge that I just created, I'll choose the option host. Why? Because as you saw previously, let me clear this one up. If you do docker network ls, one of the networks you have is this host network. Okay, so you can pass in that option there. So if I do this, and let me remove this option for now because I don't need it, I have Nginx running locally. Okay, what does this mean? This means if I open the browser and just type localhost, I'm on Nginx. Okay, because even though it's running on a container, and as I showed you here, I didn't do -p to publish the ports on my machine to the container ports, because I have this -- network host, so everything is merged on the host network. I can directly access this here, okay, with localhost. Okay. And now what happens if I go to the second terminal and do exactly as I did before, but of course changing the name to bridge 2? What are you expecting to happen? Well, as you can see, we cannot bind port 80 because port 80 is already bound by this process here. Okay, because we are on the same network as the host, everything is under the same network, you should expect these port collisions to happen. This is what you get when you use this host network option, okay? That's why sometimes it's tricky to use. You should only use it in very specific situations, okay? You might be wondering, okay, I can maybe use this option if I want to access services that are on my local, on my host server. Let's assume that you have a database running locally, or you have an API and you want your container to be able to access that. That's probably not the best option. We will see now an option if that's what you want to do, what's the best way to do it. But I mean, that's you will rarely use this host network option, but at least you know if you need it that you can. So if you want to access your host's services or anything in your host machine, we would use something called host.docker.internal. Okay, this is how you would access things that are on your host machine. So this host.docker.internal is a special DNS name that allows your containers to be able to access the host machine. So by accessing the host machine, I mean any databases that you have locally, or any APIs or whatever you have locally that is running on a specific port, you can access from the container. Okay, we will see this in practice if this is a bit confusing. So if you do something like ping this inside a container, you will ping this. This will resolve to the IP address of your host, of your computer, as it is perceived by Docker itself. It's not actually a public IP or anything. It's just the IP address that your host, your machine, is perceived within Docker, and this is normally called a host gateway. Okay, and you get this IP from Docker itself. So as I just told you, you would want to. This is more commonly used, to be honest, this host Docker internal than using the host network. But you would want to use this, as I told you before, if you have anything running locally that you want to access from within your containers and you don't want to containerize everything. Okay. So before we go to a practical example, let me tell you that this host Docker internal, it works somewhat okay-ish in Windows and Mac, but you may have some issues also on them. And in Linux, you sometimes may need some manual work. Beware of that. But yeah, having that said, let's go to a practical example of this host.docker.internal. So the first thing that you need to understand is that whenever you have Docker Desktop installed, you get this entry added to your hosts file. If you are on Mac and Linux, you can find the IP address for this or the resolution for this host name in your /etc/hosts file. But if you're on Windows, you have this file on a bit of a trickier path. So you would find this path or this IP on C, Windows, System 32, drivers, etc hosts. Okay. You should have this entry added to your hosts file, but if you're using Docker Desktop, otherwise, if you don't have this entry, you have to manually add it. And whenever you have this IP address here, you can just add 127.0.0.1, something like this. Okay. If you don't have this entry manually added by Docker Desktop or by any other tool you use. Okay. So that's the first prerequisite. Please make sure you have this added. And in case you don't add it with this 127.0.0.1. Okay. So what are we going to do now? We are going to run this server here that I created quickly. And the point is, from within our container, we are going to be able to access this service that is running locally on our machine without the need to have everything on the host network and so on. Okay. So the first thing that I will do is I will remove this all the containers again. Okay. And I'll do node, and this will do for any programming language, any tool you want to use, as long as you have a server running locally. So I already have this address locally, so maybe I just need to change this to 3100. Okay. And I have this running at this port, and if I copy it and go to a browser, you should be able to see this on localhost. Okay, so this is running on localhost 3100, and if I go here, you should be able to see it here. Okay, should be able to see it here. Now, let's, since we have the server running locally, let's create an Nginx server or any container for that matter, as long as it has curl, and try to get this from this localhost 3100. Okay, so let me now run Nginx, not on the host network. Okay, I just want this to be bash, and I want this to be -it. Okay, good. So the first thing that I want to let you know, and maybe we haven't explored enough, is that you can actually check the hosts file of your container, and you can see here the IP address that was assigned to your container. Okay? And that's something interesting. One thing that you will notice here is that we don't have anywhere specified here the host.docker.internal. Okay, this should work by default. Otherwise, I will teach you soon how you can add this here and have this working. Okay, so we can install maybe ping here. So we can do apt-get update and apt-get install iputils -ping -y. Okay, so the reason why I want to install ping is that I want to show you that even though we don't have this host.internal.docker or host.docker.internal here, we can still access it because the DNS server can route our request because it's already added there. So if I do ping host.docker.internal, even though it's not on my host file, I can still access it because my request is served by the DNS server, and I have that entrance there. So now one thing that we need to do as well is, so I have this host.internal here. I know that this will translate to the IP address of my host on the Docker perspective. And now if I want to access this service, I will not do something like this. Why? Because this local host, regardless of the strategy you use, this local host is going to map to the container itself. Okay? So localhost is the container itself. It's not the machine. But if I want to access the machine, as I told you, we have to do host.docker.internal. And by doing this, I can access the service that is running on that specific port. Okay? And as you can see, I'm on a container, on a network, even though it's the default one. And I can access a specific service that is on this port, but this port is on my machine. And therefore, I don't need to do any of those host network shenanigans, and this works, in my opinion, in a clean way. So anyway, this is all I wanted to share as far as this host internal, as far as it working by default. But you may ask yourself, what happens if I don't have this? So I cannot even ping that that host.docker.internal. Well, there's a way you can do it. Let me exit this container. So there's an option you can pass here, and let me create a third one, which is the dash dash, and this works from Docker version 2010 or something like that. There's an option you can add called add host. Add host, I think it's called add host. And here you can pass the host.docker.internal. So this is the host name. And here you would pass host gateway. Host gateway, as we've mentioned, is the IP address of your host, of your machine, as it is perceived on the Docker network. And this is the host.docker.internal host name. And when we run this and we do cat/etc/hosts, you should see here this host.docker.internal now mapped inside your hosts file. And if you do the ping again, that should work. Okay, but if you want to explicitly pass this option, you can to enforce on the host file of the container this configuration, but as I showed you before, it can work without it. Okay, so that concludes everything I wanted to share about this Docker networks. This is supposed to be a very basic introduction. Thank you so much for watching, and I'll see you in the next one. Bye.